Excited to be here. I bet you didn't think you'd have two back-to-back lightning talks on LLM observability tonight, did you? Quick intro, I'm Sage. Like Bill mentioned, I do a lot of stuff in Seattle. I live over here. I help run a lot of the meetups in the area, so you might have seen me around at some of the data or Python meetups. We're hosting a Python meetup tomorrow on advanced topics on machine learning. You could check it out. And then I work at Y Labs. We also enable observability and ML monitoring across your whole data infrastructure. And I'm going to be talking a little bit about what we're working on today, specifically around large language models. And if you want to stay connected with me, find me on LinkedIn, ask me any questions there. And you can also connect to me at sage@ylabs.ai. So what is ML monitoring and observability? I don't think I really need to go too deep into this, so I'm going to go pretty quick. Also, this last talk, I know we probably want to hang out after this. But once you have a model in production, usually there's a lot of things that can kind of go wrong or something may happen. So we have a saying that says bad data happens to good models. And I also have stickers of that. So if you want to get a sticker, come talk to me after. And I totally forgot to say, we also have those YBot stress balls. I have a whole bunch in my backpack, but instead of throwing them out like Eugen is suggesting, I'm going to have you come up and talk to me afterwards. But I have a whole bag full, so please take some. But yeah, so typically across machine learning models, especially if it's tabular data, you might have put a model in production, experienced things like data drift or concept drift, where your data is changing coming in, and your model may not be outputting the results you're expecting. And this is a little bit harder to monitor with LLMs because the data looks a lot different than you might think. And I'm going to skip over this a little bit, kind of how to think about, or I'll just go quickly. Analyzing change in an application. So what are you looking for when you monitor? And the last talk already actually kind of talked about this, so that's a really good setup. But essentially, in your whole ML application, you don't just have the model; you have all the other infrastructure around it. So it's really good to establish where a change can occur. And with most models, if you don't know where to start, I always recommend get the inputs directly go into the model and the outputs directly coming out of the model. Just that alone can usually catch a lot of things that might even be triggered earlier in the pipeline. So if your data is changing and it doesn't look like you're expecting it to look at the inputs, if something probably broke earlier on or you had some sort of quality issue. Or the data drifted. And then obviously getting ground truth is great. So you get your score later on, like your F1 score, accuracy, et cetera, that you want to measure. But that takes usually a human in the loop to generate the data annotation. Once you kind of know what you want to measure, so if you just had the inputs and outputs as a starting baseline, you want to know what type of change to look for. That could be at the start, I often recommend people just use their training data as a baseline if you want to look at input to your model, see how the distribution relates to your training data, or you can use a rolling window. So if you're looking for anomalies in like a 7-day or 90-day window, you can select that as a change to monitor. And then you want to analyze it. So it comes into often like a data scientist or in these platforms and stuff that you're seeing pop up now around ML monitoring, you can choose different values or they'll recommend one for like what type of distribution distance you should select for your data drift monitoring. So now that you saw this here, we just went really quickly. You also saw another talk on it. Who thinks that monitoring an ML model in production is a good idea? Raise your hand. Some people didn't raise their hand, so they don't think it's good. They're really confident in their models and data never changing, or they're working in a different application where they feel like they don't need to monitor it. So most people raise their hands though. Who here is monitoring models in production? See like 5 people out of like the 100 or something here. But hopefully today, after today, you've seen the last talk, you'll see this, and maybe you'll look at these tools and start implementing monitoring in your models. So tying this back to large language models, you're likely familiar. We've seen a lot of talks on this already tonight, but you're likely familiar with most of the large language models out there, ChatGPT, et cetera. And there's a lot of great, exciting use cases. Most of the ones I've seen or have worked with have been around in chatbots and summarization. And I'd love to, if, do you have an input? Which one? Oh, I think this is OpenLLM. It's one I haven't used in a long time. And then Dolly is in the middle. DOLY, but that's a Databricks one. And then they acquired Mosaic, and I'm assuming that logo is going to be swapped out for Mosaic at some point. But I made this before that happened. So what are some common pain points with LLMs? Like many people have also talked about earlier, you have hallucinations where you're getting irrelevant or inaccurate responses that can be risk prone. You have responses show subjective experience. Prompt engineering, this is a big one, and a lot of people I talk to with LLMs in production right now, this is a huge thing. So you're typically giving your model a system prompt, telling it how to behave, and then you're often updating this over time. Like you put it in, and then you update it, trying to improve your responses. But many people aren't really monitoring how much this is actually improving. They're just kind of like, well, I think this prompt is working better, and maybe you do a quick test on some golden prompts. Is anyone doing this already in production? Like, do you have a model out using GPT-4 or something, and you're giving it a system prompt, and then you say, hey, I think I can improve the answers by adjusting that prompt? I see several people. And are you monitoring it, or is it like you're just kind of do it and everyone's shaking their head? So you do it, you feel like it's doing better, and it totally might be. I think, gut feeling is a good thing to start with, but how can you actually monitor over time? Or how can you do that like 10 times at once? And like you might want to do 10 iterations of that prompt and then deploy it. And then maybe over weeks worth of data, you can say, oh, this one prompt out of those 10 worked better, and then deploy that one. So we'll talk a little bit about this, or a little bit about that later. And then you'll also want to validate your outputs. Are the responses giving you the right category, right category? I was evaluating responses once, and it was returning a phone number, but I never gave it a phone number. And it was in like a support use application. So it's just telling angry customers, oh, you're angry, call this fake phone number. Do you think that would make them happier or more angry? And I wouldn't have known that because I just didn't think like, oh, I needed to provide this example with a phone number. I didn't tell it to provide it. It just started doing it. So I thought that was really fun. So how do we solve all these problems that we just kind of touched on? In some cases, you'll need guardrails where you can kind of look for, maybe prompt jailbreaks, people trying to get around those security measures you put in place in your large language model. For example, or also you want your model staying on subject. For example, if I have a financial chatbot, maybe I don't want it giving medical advice. That doesn't sound good. It wouldn't be trained on that. And I'm sure there's going to be a lot of these interesting use cases where chatbots are everywhere. People are going to be asking it different things. And then it's probably going to be replying to a lot of it unless you're checking that, the responses remain in that subject. Pattern matching, like I mentioned, that can catch the phone number. Sometimes also I've seen use cases where it generates like a credit card number. And I hope that's not a real credit card number. Evaluation. So like I talked about, comparing your prompts over time is a huge one. And then with your responses, you'll be wanting to check things like, at least in the use cases I've looked at, like sentiment over time, readability, different stats around it. So how do we do this at scale? We have a open source library that we made it at YLabs called LangKit. You can find it on GitHub, just Google LangKit. I'll have a link at the end as well. This kind of works where you can pass in prompts and responses from any large language model, and it's a Python package. It integrates in with basically any pipeline, as long as you can structure a prompt and response in a dictionary format. And we also have integrations with like LangChain, so it's really easy with some of the other popular applications, but it kind of works at a high level. Again, any large language model, you get a prompt, you get a response. You'll use this open source toolkit to extract different language metrics out of it. And we'll see what this looks like in the next slide. I'm just going to touch on, again, it's open source. It's easy to integrate with most existing tools. It also has other integrations, and then it's also extendable. So we're going to talk about some out-of-the-box metrics that are really useful, but you can easily add in your own metrics as well. So at a high level, it works something like this. Get a prompt. That prompt is going to a large language model by the end of it. Might be going through some other pipeline at first as well. And you could extract these metrics anywhere in there. But in this case, we're getting the prompt. We get some patterns around this, like sentiment score, this is, somewhat negative in this case. It's minus 0.52. It's, not a high jailbreak similarity. It's not very toxic. The reading level is fine. And then we get a response, and we get all those same stats back on the response, as well as some other ones, such as like response relevancy, which is calculated by, I think, the prompt and the response embeddings. And then you're seeing basically, did this do a good job? Some of the out-of-the-box metrics Our response relevancy has patterns. These are some predefined patterns like the credit card, phone number, et cetera. Sentiment, toxicity. It's fun also if you just type in things to see like what words are really toxic and stuff. Jailbreak similarity category. So like I mentioned, there's some predefined ones for the model. So it could be like, oh, this is financial advice, this is medical advice, this is customer support, et cetera. Difficult words, reading score. So all these metrics get extracted out from the prompt and response. And there's a lot that we can do with those, and we'll dive in with that quickly in a second. But also just want to mention, again, Python package, it's easy to use. If I see Bill's on my screen. Hey, Bill. I'll minimize that. So if you want to use this just an open source library in your Python environment, you can just import LangKit, import LLM metrics. You can define a schema. So this is, you can also add custom metrics before this. If you just call this right now, it gets all those out of the box metrics. And then you just call this y.log, pass in, again, that dictionary format, just prompt and response, and you'll get a profile of that data. The profile, this is viewed in pandas here, but it's just a very long pandas data frame. Behind the scenes actually in protobuf, but if you view it in pandas, it's a really long data frame where you have a whole bunch of the metrics around it that we saw earlier. If you want to easily write it to YLabs, which is our AI observability store, where you can take those metrics and then ingest them, visualize them, configure monitors with just a few clicks. You can do that but with importing the YLabs monitor. Here's an example of just like sentiment over time. So this is like a week's worth of data. You can see on one day, it drastically changed. In this case, I think it's actually getting more positive. So that might be a good thing. Maybe you changed a system prompt and people are really liking interacting with your bot where they weren't before. But typically, like if you change the system prompt, you might be wanting to make sure, oh, the sentiment didn't go down in my responses or something like that. And then you can easily add any custom language metrics. So we have a lot out of the box, but you might want to add stuff in. So you might actually want to query like a vector database and get some sort of distance score in there. Like Zillus, if you remember, was that a database? Also one like I've used in applications is detecting language. There's an easy Python library called, I think, just lang detect. You can import it, pass in a string, and it'll return like English, Spanish, etc. Then you can store that as a response too. So if you're doing a translation service with an LLM, you can make sure that it is providing the correct language back, or if you're supporting multiple languages. And I know we're running out of time, so I'll go pretty quickly. So there's some options for monitoring data and ML production at scale over time. It just depends on your application, what you might want to use. You could store the full data set that sometimes can be costly to transfer, store, and analyze. You can do a uniform random sample of your data set. Sometimes you might miss outliers. And then you can do aggregate statistics. That's kind of inflexible, not very mergeable. Or you could do something that we do with YLogs, which is our other open source data logging library. It uses Apache data sketches. What that does is it kind of solves these issues above where you're creating these statistical profiles of your data, but you can merge them together. And so none of your raw data by default actually is contained in this profile anymore. It's just like, for example, you could think of it if it's tabular data, the min, the max, the mean, et cetera. In this case, with language data sets, we saw some of those statistics. So you get like a sentiment score, et cetera. With that data, it's actually really powerful that you can extract all those metrics and understanding over time, have those alerts triggered and detect data drift. And just a quick mention on scalability. So with data sketching, it's incredibly efficient and lightweight. So we have some metrics. We have a whole blog post on this about how quick you can profile millions of rows of data incredibly quick. And then they're incredibly lightweight. They don't, their storage amount isn't very much that they take up. So they're also easy to pass off of different devices. So I've worked a lot in like computer vision and edge devices that can be really costly to pass images off. But if you can collect just the lightweight statistics from your data and then pass them off, that can work really well. And it easily integrates again into most pipelines, or specifically also with the YLabs AI observability. You would have your infrastructure here. You have this library YLogs or LangKit collecting the privacy preserving data statistics. Again, so there's not raw data by default in here, and then you're passing that out into your observability platform. And then from there, you're generating reports and dashboards, doing alerts and notifications or triggers and workflow. So I think also in the other talk, Mentioned kind of having a loop. Typically, you're going to iterate on these models over time. Has anyone deployed models and then like you retrain a model and then deploy it again? See several people, right? That's kind of the typical workflow. Once you deploy a model, you're probably going to want to be collecting new data from production, often annotating it, retraining your model, making it more robust, and then deploying it over time. And just a quick screenshot of like, here's by default, if you upload some of the data, here are some of the patterns that come out with that pattern matching. So you can see in this is actually just from a HuggingFace data set here. And it has several things it's caught automatically, like patterns, contains an email address. There's one that looks at least like a jailbreak, had negative sentiment, the reading ease, you know, if it was really high, it might say, hey, you might want to tune your system prompt or fine tune your model so it's giving easier to read responses. And this is what I was saying in my application that I was building, actually caught that it was providing phone numbers out when it shouldn't have, which I thought was pretty funny. And then just a quick look again at what some of these metrics might look in a time series view. You can see on this day, this is measuring prompt sentiment with an LTK model, and it drastically dropped this day, and then that's going to trigger alert for us probably to go look and figure out why that's happening. And I think I'm probably at time. And I know, yeah, I think we're at 8 o'clock, and I definitely want to hang out with everyone. And again, I have those whitebots and everything that I'll give out in our in my backpack over there. But here's all the resources. So there's a quick demo notebook if you want to run some code. It'll also generate those profiles. You can mess around with the different inputs. We have a LangKit repo. Always appreciate a GitHub star as well. So if you're logged into GitHub and you go to LangKit, we love a star on our open source projects. We also have the YLogs one. So we want to look more at just data logging for ML applications in general, you can. And then if you want to stay connected, you can find me on Sage Elliott or Sage Elliott on LinkedIn.